Hello everyone and welcome back to the channel. In any distributed system, data is constantly moving between services and from databases and between clients and servers. But how is that data actually packaged and structured for communication? While JSON is incredibly popular, choosing the right data format is a critical design decision with huge implication for performance, interoperability, and maintainability. In system design interviews, discussing your data format choice demonstrates announced understanding of trade-offs. Today we are diving into the key formats you should know and when to pick them. Okay, so first, what are data formats? At its core, a data format is a standardized way to represent and organize digital data for storage or transmission. Think of them as different languages that software components use to speak to each other. Their primary purpose is interoperability, which is ensuring that systems built with different programming languages, operating systems, or even technologies can reliably exchange and understand data, basically understand each other. Without a clear format, it would be like a pure chaos, like trying to have a conversation where everyone speaks a different undefined language. Okay, so right now we know what is data formats. But why data formats matter that much in system design and why it will be matter in your system design interviews? So first, performance. The format directly impacts how fast data can be serialized, converted to bytes, for example, and deserialized, which is converted back to objects, as well as the actual size of the data, which affects network bandwidth and storage costs. Number two, interoperability. It dictates how easily different parts of your system or external systems can communicate. Number three, human readability versus machine efficiency. Some formats prioritize being easy for human to read, while others are optimized for machine processing speed and compactness. This is a trade-off. This is an important trade-off. Number three, schema evolution. Basically, how easily can your data structure change over time without breaking existing clients or services? Lastly, interview insight. We'll talk about this. Basically, discussing data formats shows you think about the fine-grained details of data transfer, which is crucial for building robust systems. Okay. So we talk about key data formats to discuss in any system design interviews. We will talk about the pros, the cons, and when to use every one of them. So first, we'll start with JSON. I would say this is the most famous one, which is short for JavaScript Object Notation. It's a human-readable, extremely widely supported across almost all programming languages and platforms, especially on the web applications. It's flexible and relatively simple, often considered as a schemaless or schema on read. The cons of it, it's quite verbose because it takes up more space than binary formats, for example, which can impact network bandwidth. Parsing also can be quite slower than binary formats. While it's quite flexible, the lack of an explicit schema can lead to runtime errors if data formats aren't strictly managed. Okay, so when to use JSON? It's, I guess it will be the king for RESTful APIs, configuration files, client-server communication in web and mobile apps, and often for logging due to its readability. Number two, extensible markup language. The pros of it, it's a highly extensible with custom tags and has strong built-in schema validation capabilities, ensuring strict data structure. It was historically very widely used, especially in enterprise integrations with protocols like SOAP or SOAP. The cons of it is extremely verbose, even more than JSON, leading to very large, massive sizes. message sizes. Yeah, it's also complex to parse and process programmatically. It's not that easy. If you work before with XML, you know how hard is it to work with. When to use it, I would say use like you will use it in legacy systems. You can use it in enterprise integration that rely on SOAP or SOP protocols, or in highly document-centric data where strict schema validation is paramount. So number 3, we have a binary serialization format. This one is quite new. So I would say this is quite new in system design interviews, because you will not face it that much. But I guess in the upcoming interviews, you might face it. These formats are incredibly compact, leading to very small message sizes and significant saving on network bandwidth and storage. They are also extremely fast to serialize and deserialize because they are designed for machine efficiency. They often come with a strict schema definition using an interface definition language, or IDL, that forces strong typing and provides forward-backwards compatibility. They are entirely language agnostic. Okay, the cons of it, I would say they are not human readable at all. You can just open a protopop message in a text editor and understand it. It will not work at all. They require a schema compilation steps in your system and your build process as well, which add more complexity. Also, they have a steeper learning curve compared to JSON, for example. Actually, you don't need to have any learning curve to JSON. JSON, it's pretty easy to understand. But when to use this one, I would say this is ideal for high performance microservices communication, like any gRPC. Internal messenger queues, you can use them in Kafka. Often uses I guess Avro or something like that. You can use them in data serialization for long-term storage, where compactness is quite key. And I would say in any system design interviews, when you are designing a microservice architecture, your interviewer might talk about binary serialization formats when he talks about when he says something like, okay, we have a problem here. We might have some sort of latency because a lot of different services are talking with each other. So how we can address that? So binary serialization is one of the things that could solve this problem. It's not the only one though, but it's one of the things. Lastly, we have CSV. I'll say this is the simplest format imaginable. Like, it's a very human readable for basic data, and it's universally supported by spreadsheets, programs, and simple process. It's the simplest thing. I guess the cons of it, because it has no inherent data types, no support for complex or nested data structure. It's just flat rows and columns. That's it. When to use it, I guess you can use it in simple data exchange, bulk imports, exports, maybe basic log files, or when interacting with spreadsheets applications, for example. Okay. This is the most important part of the video. So how to choose the right format in your system design interviews. So in an interview, when you've been asked about data formats, there is no single best answer. Okay, the key is to justify your choice based on the specific system requirements. For example, if you prioritized human readability and developer experience for public-facing APIs, where ease of use is quite paramount, there is no other choice but other than using JSON. If you prioritize performance and compactness for high throughput, and also for internal service-to-service communication, you will use like a protopop, or basically you will use a binary serialization format. If you consider schema evolution needs and how it will breaks, I guess you will use something like XML. And if you're working with a pretty old system, if you're working with a pretty legacy system, you will use XML. I guess if you maybe working with this simple data, like the simplest way of working with data, and you need data to be really human readable, I guess you will use CSV. So that's it. So data formats are the fundamental language that allows disparate software components to communicate effectively and efficiently. Your choice profoundly impacts systems performance, interoperability, and long-term maintainability. Mastering this topic shows a deep understanding of the practicalities of build robust distributed systems. And yeah, so that's it for this video, and thank you for watching.